This is the fourth part of the Physical Techniques in Inorganic Chemistry unit. We're going to look at ionization-based techniques, most especially mass spectrometry. Now, mass spec is a technique used for determining the mass of a molecule and its fragments. It uses the mass to charge ratio of gaseous ions, so irrespective of their charge, so long as we can get them in ionic form, then we're able to determine their masses. It's a very destructive analytical technique. The sample cannot be recovered, but it gives us very, very valuable information. There are different experimental arrangements that will produce these gas phase ions for us to analyze a sample by mass spectrometry. The first one is called electron impact ionization, where the sample is bombarded or irradiated with high energy electrons that cause vaporization and ionization. There's a disadvantage to this particular experimental arrangement in that it causes considerable decomposition in larger molecules and makes it difficult for us to get our valuable information. The second method is called fast atom bombardment. This bombards the sample with fast neutral atoms, which causes vaporization and ionization. And its advantage over electron impact ionization is that we get much less fragmentation with this particular technique. The third one is called matrix-assisted laser desorption ionization, otherwise known as the MALDI method. It is similar to electron impact, except that instead of using electrons, we use a short laser pulse to vaporize and ionize the sample. It is used mostly with solid and polymeric samples. The fourth one is called Electrospray ionization, where droplets of solution containing the ionic species are sprayed into a vacuum chamber. The solvent evaporates and then we get individually charged ions which can then be analyzed further. In terms of the instrument types, there was an older traditional method of ion separation which is rarely used nowadays. We have a look at the mass to charge discrimination, which we find accelerates ions with an electric field, followed by a magnetic field that is to deflect moving ions. Now, the magnetic field is a magnet that is actually moved that causes the ion path to be deviated, as shown in the drawing at the bottom of the slide here. The more modern methods of instrumentation include a quadrupole mass filter. This uses an oscillating electric field between 4 parallel rods to separate ions. Remember, guys, from physics that when we're using an electric field, we generate a subsequent magnetic field. So if we're then going to move these quadrupole rods, we're going to cause the field to oscillate, and then we're able to direct the ions to the detector in this way. And the last one is the most common instrument. It's called a time of flight instrument, where ions from a sample are accelerated by an electric field for a fixed period of time, and then those ions are allowed to fly freely. So the force from the field on all the ions of the same charge is the same. So the lighter ions are accelerated faster than the heavier ions, and obviously are detected sooner than the heavier ions. And this has great advantage for getting our mass spec information. So this is what a mass spectrum looks like for a molybdenum coordination complex. And you will see that we have these groupings of peaks, which indicates the masses of the ions at different points. It's much clearer on the next slide, where we look at the mass spectrum of mercury. Now, mercury is obviously a single element. This shows the isotopic composition of the atoms. So you can see that at these different masses over here, so we've got a mass at 198, we've got a mass at sort of 199, a mass at 200, a mass at 201 thereabouts, one at 202, and one at about 204, close to 205. So this is the different isotopic spreads of the different isotopic ranges of mercury itself.